other ones that are worth less, or are they going to cover just whatever was before?
Okay, good question. So exam 2, look at exam 2 and 4 as like midterm and final. So exam 2 will cover the first half of the class. Even though you're going to take exam 1 online on your own time, there will be material from that exam on exam 2, just not as much.
Okay.
And then after exam 2, you'll have exam 3, which only covers material after exam 2. And then exam 4 will cover both exam 3 material and exam, well, the material after exam 3. So look at exam 2 and 4 as like 2 halves. That's what they cover. Good question.
Thank you.
Mm-hmm.
Is there going to be homeworks after each lab and lecture?
Pretty much. They're not, like, some lectures will overlap. So you might have a lecture that actually goes and covers like one section and then starts another section.
Okay.
So there might be some overlap there, but each homework assignment is based on a specific section.
Okay.
And there is something I did fail to mention on the orientation video. The slight difference, right now I'm sharing my screen. In the in Cal 1, I actually have like 3 main types of videos in Cal 1. I have what are called course videos, which are videos of me talking about definitions and theorems and things like that, kind of giving you the gist of everything. And then you have the class lectures, which is where I'm actually in a classroom covering my notes and going through specific examples. And then I have the homework solution videos. So for Cal 1, there's course videos, class lectures, and homework videos. For Cal 2, there's only the lecture videos and the homework solution videos. Not that Cal 2 is getting anything less, it's just, that's how I initially set up my Cal 1. And then for Cal 2, everything is just the lecture. So.
So do you just like post the lecture each week? You post some more material?
No, they're all out there right now. So
we
like,
could work ahead if we wanted to.
Yeah. So like here I'm looking at the Cal 1. If I go to my course videos for Cal 1, it's going to take me to a YouTube playlist, and then I can watch those whenever I want. I can watch however many I want. It's all here. The whole semester's there. So you can start going through that, and then you can watch the lecture videos, which is another YouTube playlist. Again, you know, watch them as you please, move at your own pace. And then on top of that, I also have older videos too. You know, if you want, just, I think some of my older videos, or other videos, optional videos, are just me in a different classroom. So it's a ton of videos out there. I mean, it's a ton of material. Students who've done well in this online format have followed through with watching the videos and then doing the homework. I think this summer, more than ever, it's going to be important that you're paying attention to what I'm saying in my lecture videos, because exams 2 and 4 normally, and like pre-COVID-19, my exams 2 and 4 were done in WebAssign, but you had to come on campus to do them. So the format of the exam was very similar to what you're used to seeing when you're at home. This summer, I'm changing it up, and so the exam that you're going to take, exam 2 and 4, are not going to be on WebAssign. They're going to be good old-fashioned paper pencil tests. Now they will be problems that are either similar to what's in WebAssign, or similar to problems that I've done in the lectures. So as long as you're watching the lectures, you're good to go. I mean, in terms of there's no surprises. And you know, I'll give you some idea when we get closer to exam 2 and then exam 4, I will give you some idea of what to narrow your focus on, like the types of questions that I might ask. You know, calculus builds on itself pretty quickly, so by the time we get to exam 2, I may not be asking any questions from the first few sections because one question from a later section covers all of that, if that makes sense. It's like it's built in already. So you don't want to go back and start redoing problems that you're not going to see on the test because they're almost too easy at that point. So.
So are we able, like when you say that we can go ahead on those videos, are you going to have the material that we need to turn in already posted so we can continue to work ahead, or do we still have to go at a certain pace? Like I took my first algebra class I took it online, and the professor allowed us to finish the semester as quick as we wanted. If that was earlier or later, he said whatever, but there were still specific dates things had to be due by. But if we wanted to work ahead, we were more than welcome to.
Yeah, yes and no. You can do everything at your own pace with the exception of exams 2 and 4.
Okay.
Those have to be done as a group together. And that's just for fairness. And, you know, once I've given an exam, you know, it's out there. You know, just to be fair, level playing field for everyone. Everyone will take exam 2 and 4 on the same day at the same time. But if you,
Okay.
you know, if you want to go do everything else, do all the homework assignments and take your other online exams, the exam 1 and 3, if you want to do those on your own and have the whole semester knocked out and just show up for exam 2 and 4, it's fine with me.
Okay. All right. And are there quizzes that will also be online as well?
I don't do any quizzes. It's all homework, and you get multiple tries at each homework problem. This is really, I'm not trying to give you busy work. The homework is really just so you can get some feedback. You know, I mean, with the way things are these days, online course, you know, you can go find the answers to all these questions very easily. And, you know, I usually have 2 types of students that do the online calculus. You have students that really are here to learn, and then you have others that are just trying to find the shortest, easiest path. And so they go and they don't watch the videos. They get hundreds on every homework assignment, and then they show up to exam 2 and 4 and just get completely blown away. And that's usually because they're not really putting in the time and effort to work through the problems. The other students are the ones who do everything, and they usually do well. What am I trying to say? No quizzes because, like I said, the homework is just practice. I really want you to practice, and I don't want there to be any pressure or, you know, like where you're freaking out. You know, you can freak out in exam 2 and 4. That's going to be the true test. And I know that's a huge percentage of your grade. 35%, that's huge each exam. I can remember as a student in undergraduate school taking courses where we had just midterm final. That's it. 50-50, 2 grades, your whole semester. Depends on what you can do in about 3 hours. So, you know, I think the only way to get past that sort of anxiety and pressure is to just make sure you understand the material, you know, and that's going to take time. Cal 2, some of you may be retaking this class. I don't know how many of you, I have my Cal 1 and 2 here today, so I don't know how many of you here are Cal 2. But, you know, Cal 2 in 8 weeks, if you've never seen Cal 2 before, Cal 2 in 8 weeks is, you really need to have time. Like, I really hope that you have time. You can do it. I've had students do it. It's just, you have to be realistic about the expectation. the multiple hours of not only learning, but then you going and practicing. You know, Cal 1's a little bit less, you know, there's not as much, but, you know, the Cal 2 especially, y'all are going to have to really be ready to hit the ground running like right away. Because I think we have 2 sections already, pretty much right off the bat.
Okay.
You know, I think the first due date, let me see here. I'm looking at just Cal 2 right now. But I believe for both Cal 1 and Cal 2, you'll have the same first due date. Well, the 11th, but that's not even really calculus. It's just some stuff, administrative stuff. Your first due date's on the 14th, which is
Sunday.
This upcoming Sunday. So, and it's 1, 2, 3 sections. Yeah, so, and those first sections are not that bad. In fact, the first 3 sections are kind of an overlap. For the Cal 2 students, some of it should look familiar, especially you probably talked about antiderivatives already in Cal 1. So really, when it starts to get real is right about when you hit chapter 6. So, you know, that's when we get into the techniques of integration. So the way Cal 2 works is we do some ancillary stuff about trig functions in the beginning. Make sure you understand what an antiderivative is. Then you go through all the techniques of integration. And that's a good, heavy topic there. Once you get past that, you go into applications. Once you get past applications, you get into chapter 8. So for Cal 2 students, chapter 8's the monster. That's the monster. Sequences and series. And
Okay.
maybe you've heard that already, but you know, that most of the time that's bad only because it's new. Like it's really new to a lot of people. Like you've never seen it like in some high school math class. Usually it's brand new. For Cal 1, it's just kind of like opening your eyes to this new world of math. It's, you know, college algebra and pre-cal has all been very finite math. You know, you do a computation and it's a finite process. And in calculus, we're doing infinite processes. So it's kind of like just this realization that there's a whole new way to look at things.
So when you say that you can turn in your homework and get like second chances on your homework to do the problems and such, do you just like give it back to us with feedback and then we make correction and turn it in again for a grade?
Well, the computer's going to grade everything. So
Okay.
the computer's going to give you the feedback, which is good and bad. I mean, it's bad in the sense that it's a computer, so how good can the feedback actually be? But at least you know if you're getting it right, that you know you're doing it right. Remember that I have my homework solution videos. So
Okay.
you always want to be able to refer to those. And I'm going to share something with you all right now that I didn't share in the orientation video. It's a little confusing, but it might help you. All right. So let me bring this up here. Trying to think of how I can. Okay, let me start with Cal 1, okay? let me address this to the Cal 1 students. I do have Cal 1 students in here, yes? Is at least one person here in Cal 1?
Yes, sir.
Okay. Okay, so Cal 1 is still kind of like, how do I say this? I still handhold a little bit in Cal 1, like, come on, we're gonna do this, let's go. You know, so with the Cal 1, if you can see my screen, I have the homework solutions for the Cal 1 students. And it's actually me working out problems directly from WebAssign. So WebAssign is where you go to do your homework. So like in this first video, let me open it up. Oh, good, I'm muted. I'm gonna make this bigger here. So hopefully you can see, like I'm in WebAssign and there's audio. I have it muted right now, but it's me actually looking at the exact problem in WebAssign, and I'm gonna work through that whole problem. And I start writing on the screen at some point here. Yeah, so I'm writing and I'm talking. And so I actually, in my Cal 1's class, every problem that you see in your homework, like I'm gonna work it out in the homework solution video. Now, if you notice the numbers are red here, what that means is that your problem might have 4s in it like this, but another student might have a problem that has 8s in there. Like the red part of the problem is the only thing that changes from problem to problem. So if you practice another problem, that's the only thing that's going to change. So if your problem has 8s and mine has 4s, you should be able to follow this format and figure it out. And I do that pretty much for the entire semester. All of the homework assignments I've got a video for. That makes sense? So Cal 1, I mean, it's pretty straightforward in terms of how you can get help on the homework. Cal 2, a little trickier. And the reason why is because the Cal 2 homework takes probably 5 times as long as the Cal 1 homework. Like if you were to look at all the homework for the entire Cal 1 course, how much time that takes me to do, the Cal 2 is probably 5 times as long. So I didn't do the same thing for Cal 2. So let me show you what I did for Cal 2. So for Cal 2, you got to work a little harder to get the help. So if you notice here, it says homework solution videos for my face-to-face class. So what I do have for my Cal 2 students is me working through all of the homework problems that I assign my face-to-face class students, or my face-to-face students. So let me just bring up an example. Here's the homework solutions for 5.5. And you can see here, I'm working out number 5. Do y'all see that? Up in the corner, I have number 5. So I'm working number 5 out of section 5.5 out of the textbook. That's what I'm working out right there. Now, for my Cal 2 students, when you go to WebAssign, okay, so I'm gonna go to WebAssign and I'm gonna go look at that 5.5 homework. So do you see on my homework video there, it's not me working just on the WebAssign page. It's like me just doing a problem on the board. So let me go to 5.5 right here. Let me view it. Okay, so here's what my Cal 2 students will see when they open the homework for 5.5. So there it is. So the problem that I'm doing here on this video, if I can get that back up here, this problem right here, like what problem is that in the homework, right? Like, is it number 5? Let's see. It's actually not number 5. This problem is not the same. Maybe I can split this into 2 screens. Nope, oops, that did not. Okay, so there's number 5 that I'm working, and you can see number 5 here is not the same. Do y'all see that?
Yeah.
Yeah, so here's the trick. So what you do is when you're looking at the problems here, go over here to the side and you'll see, I'm gonna try and highlight it. It says here 5.5.007. That means it's number 7 out of the textbook. Which one was I doing out of the textbook?
Number 5.
Number 5. So you see this one right here? That's the one. That's 5.5.005. So this problem here should be very similar to what you're seeing me do on that video. And it is, if you look at it. It's a little different, but it's basically the same thing. Here you've got cosine cube theta, sine theta, d theta. Here you have cosine to the 6. So what's the difference? The difference is that 6 and the 3. But the actual technique is all the same. The problem should work that way. So let's try and jump to another problem. Let's just pick one at random here. Let's do this one. So number 10 in the homework for Cal 2. should be number 19 out of 5.5. Let's see if we can find number 19. Did I do number 19? Let's see. So I'm just going to kind of jump. Number 15. 18. Ah, there we go, number 19. So I'm kind of in the way of the problem here. It should be good. Right there, you see that e to the x square root of 1 plus e to the x. Well, it's close. E to the x square root of 19 plus e to the x. So the 19 and the 1 were a little different, but again, it's the format, it's the procedure. So I would say for my Cal 2 students, you have to do that little cross-referencing if you're going to go try and get like video help for the homework. 95% of the problems in WebAssign, I have a video for. There might be a few that I don't, but I might have the problem right after it. So maybe in WebAssign, it's number 12. You know, it says number 12 in the book, and I did number 13. So hopefully there's enough there that you can make it make sense. And what happens if you're completely stuck? I mean, you either reach out to me. I'm going to have that weekly office hours, you know. So you reach out, you can text me. Like, let's see, someone just texted me there. Let's see if that's not a student. But, you know, text me, send me a picture of the problem, picture of the work, of your work. You know, we'll get it worked out. We'll get it squared away. Does that help?
Yes.
Feel like that helps? Okay.
Yeah.
What else we got here? Any other questions?
Do you know how long we're gonna have on the exams?
Okay, good question. I would probably say 10 hours. It's gonna be a long exam. I'm kidding, Ricardo, I'm kidding.
I was like,
eat real well. No, I mean, I would say 3 hours tops, you know. And, you know, my goal would be that I could finish the test in like 45 minutes and then give you 3 hours. That's usually a good way to do it. But I actually don't want you to work for 3 hours. Like, I would rather have a test that takes you only 2 hours, you know, because there's only a certain amount of time that you can sit there and grind away. But the shorter the test is, the fewer the problems, the more each one is worth. And if you mess one up, it could be a whole letter grade. So I think you do probably want to have a longer test with more variety, so that way you can, you know, not blow yourself out of the water with just one thing, you know, if that makes sense.
yeah.
But let's just say 3 hours sounds like where I want to go with that.
Okay. And are you gonna give out like a review before, or are we gonna be able to?
It'll be probably a Zoom session where I sit here and bring up an old exam and show it to y'all and just be like, okay, so here's some things I've asked in the past. The danger with reviews is that I don't want to like make it so that all you're doing is making sure you can do those problems. Because for me, what's fair game is anything that you've been tested on, or any homework problem I've given you, any problem I've done in class, like in the lecture videos, anything like that is fair to me. So the review is, I like to give a review that's topic. So like I'll say, you know, 5.5, expect maybe one problem from 5.5. But 6.2, I would expect 3 problems, you know, because there's more to it. So I might help you like focus where you should put your effort into making sure you know. Because I'm sure you've all taken a test where you're like, that was the one thing I didn't study, you know. So I'll try and at least give you that. You know, in the Cal 1, I think it's, in Cal 1, maybe my Cal 2 students will agree with this, but you haven't gone through Cal 2, so it's hard for you to relate the two, but Cal 1 is still very mechanical. Like Calculus 1 is still very much like, here's a formula. It's a lot of algebra, but it's still very mechanical. I hate to use the phrase monkey see, monkey do, but it's kind of the way it is in Cal 1. It's like, okay, I show you this, and then you're like, oh, okay, I can do that. Cal 2 is different. Cal 2, there's this almost like an intuition you have to have. In the way your intuition gets good is really dependent on how good you are with the Cal 1. So like, if you're very good, the thing that's going to make or break you in Cal 2 to start the course is chain rule. Like chain rule from Cal 1. Like if you struggled with chain rule in Cal 1, that's going to be very, very detrimental, because in Cal 2, we have to actually go backwards. We have to try and undo a derivative. So, imagine in Cal 1, you had some function, you took a derivative, did chain rule, maybe product rule, and you get this big nasty derivative. Well, we're trying to go backwards now. So the more comfortable you are with how that chain rule spits things out and how derivatives of composition actually work, it'll just be so much easier for you to go back. So I may be able to show you, 30 examples of how to do these problems, and then give one to you that you're like, man, I don't know, It's not as much of a mechanical monkey see, monkey do. You actually have to, I like to tell my Cal 2 students, you're going to actually fail more than you're going to succeed as you're learning. You're going to have a problem in front of you. You're going to be like, okay, I think I'm going to try this. And then you try it and you're like, crumble up your piece of paper, 30 minutes later, throw it away. You're like, I got to start over, And so you have to be ready for that. And be willing to step back up to the plate, and you have to be willing to take a swing. You have to take a swing in Cal 2 and be ready to strike out. It's kind of like, I was trying to think of, I'm terrible with analogies, terrible, but a lot of you that are in Cal 2, you want to become engineers or computer science or whatever. And you're probably never, ever in your life going to be doing the stuff we're doing here in Cal 2. Like you're probably not going to be doing antiderivatives. If you are, you're probably going to go to a computer, because the computer, we can trust it a little more than ourselves, to not make not to make computational mistakes. It's not about that. It's about a certain mindset, a certain determination. You don't want to. You imagine you have an engineer sitting there, right, straight out of college, and you're like, hey, we need you to work on this. Are you the type of person who's going to be like, man, I better get on Google and look for the answer? It's not there. Okay, it's not there. The answers, you've got to figure it out. So are you one of those people who are just going to be faced with something difficult and kind of like curl up in the fetal position and just hope that things are going to get better? Or are you one of these people like, I'm not going to sleep until I figure this out? Like I'm just, you know what I'm saying? Like a certain just drive to solve problems. Cal 2, that is what it's all about. Like how much can you take? And then you start to make these breakthroughs, and you start to realize, wow, if I keep trying at it, if I keep swinging, eventually it's going to start to all click and come together. And I don't want to leave the Cal 1 students out here, because there's an aspect to that in Cal 1 too, also, but it's just less. It really is very, very much a mechanical process that you're trying to do in Cal 1. What else? Oh, go ahead.
I had a question. Sorry if it's seemingly trivial question, but in your best estimation, particularly for exams 2 and 4, since we're going to need to do work and then be able to turn it in, how long do you think it will take you to grade those 2 exams? basic time frame for that?
Well, the good news, I only have 2 classes to worry about. Okay, I have the Cal 1, the Cal 2. I also am doing a college algebra this summer, but those tests, they have 5 exams. So those are going to be spaced out and they're going to be shorter. And so there shouldn't be a time where I've got like 3 sets of exams in front of me. I'd say within 48 hours.
Okay.
Yeah. I mean, what I'll do is I'll just grade all the Cal 1s at one time and all the Cal 2s, and I'll just, yeah. I don't like them to sit because it's just this thing in the back of my mind, like I have to finish it. So it may be that next morning, it just depends. But I would not expect to have to wait very long. You're not going to be like waiting a week or 2. Now, I don't know how I'm going to get feedback to you. In other words, if I grade and take things off, start taking points off, I'm going to have to scan it and send it to you if you want to know what happened or what went wrong. So I'm not sure how I'm going to do that yet, because that will be time consuming, scanning everything and emailing it out. But you'll at least have a grade pretty quickly.
Okay. Thank you.
Do you all have an idea, just kind of like a verbal poll here, as for a day and maybe a time period that would be best for you, for me to be available to come on, just be here to answer questions, like weekday, weekend, morning, afternoon, evening?
For me, pretty much any time on Monday, Wednesdays, Friday, and weekend would work, because I have a physics class on Tuesdays and Thursdays. It's from 11 to 4:30. It's a lab and lecture.
So you're saying weekends? I would say
Weekends or Monday and Wednesdays. I mean, as far as time goes, I'm really flexible. If it was before or after that class, I'd be fine. But just Tuesdays and Thursdays are pretty much the days that I would personally be filled up. I don't know about everybody else though.
But let me put it out this way. Does anyone have a problem with like Sunday evenings? I mean, that's when things are due though. So I'd be a little concerned about that, but we could try like a Sunday,
I'd probably prefer it to be like a day before everything's turned in, just so like if I really don't understand something, I can talk to you or like console with you and then have more time to work stuff out thereafter instead of like as opposed to having an hour or 2.
Yeah, no, I got you. I hear you. Yeah, I'm going to have to think about how to do it. I might just offer more than one time. Hey, hold on a second real quick. Okay. Okay. Yeah, I'm going to have to think about it a little bit and find a way to send out a more formal sort of poll, because there's 14 people here and I have 60 in both classes together. So, but don't forget, I mean, you can always reach out to me. Like, if you want, I can meet with you in Zoom one-on-one if I'm available. It's just, it can't always be that, I won't always be available. So why don't I come up with a way to do a more formal poll and then just pick a time that works for most people, like majority. And then if it doesn't work for you, well, then you just reach out to me if you want help, and we'll just see how we can work it out. And then also, I did talk about this in orientation. I believe I did. The tutoring labs. So the tutoring lab, one of them at least, should have some people who can help with Cal 2. It's here somewhere. There it is. This is Open Math Lab. So they're available 8 a.m. to 9 and then 7 a.m. to 9. They're not open on the weekends, but that's just like you click on it and go to a Zoom session, and then someone in there will break you off with a tutor. So. I mean, I'm here to help you all learn. I mean, it may seem like I'm going to be disconnected from y'all because I don't like to fill up your email with like, hey, welcome to week 2. I hope y'all are doing great. Like you know, this is college. Like I feel like I've put a ton of stuff out there for you on top of, you know, everything else that's out there. I'm here, always available to try and help you. But I'm not going to be like sending you an email being like, hey, I've noticed you aren't doing much work. You're falling behind on homework. Like, I'm not going to really babysit at all. So, but if you need me, I'm here. I want you to learn. And I love math. I love talking about it. I love both the Cal 1 and Cal 2. It's such a really interesting time as a student who's in a STEM field. If you've never seen calculus, to like kind of open your eyes to this. It's, I mean, I've been doing this for a long time. I think I'm going on like 22 years now. I think I've been doing this. So I always get joy in watching the discovery process of my students into the subject. Because it, you know, if you don't enjoy this, you know, you have to kind of ask yourself sometimes, like, am I doing the right thing? Like, because you have to find some pleasure in it. Even if it's like suffering, and then you actually figure it out and you're like, that joy that you get, like that moment of like, yes, I get it. You know, that has to be enough for you to continue, you know, like you're like chasing the carrot. And hopefully you have that in you, you know, that drive. And I hope that the materials I'm providing you keep you interested. And, you know, it's a lot to ask anyone to sit down and watch hours of lecture. I mean, I can't imagine doing it myself, but it's where we are, and at least we have that, right? So. Okay, well, I'm open to questions or comments or anything.
I think that covered everything pretty well.
Yeah.
Yeah.
Anyone want to talk to me at all about what their major is? And you can bail out of this anytime you feel like you have heard enough of me today. You're free to go, but I mean, I'm here to chat for a while if anyone wants to talk about their major or have questions. Any math majors?
Hey, sir.
Yes.
I got a question. I don't know if you'll be able to respond or I don't know if you have the answer to it. Do you happen to know if that class, differential equations and linear algebra, they used to do that as one class, and then now I think they do only as 2 separate classes. Do you know if that's still a thing?
Who did you say?
Differential equations and linear algebra.
Did you say SAC?
Yeah.
Okay, I thought I heard you say SAC. So you're saying, does SAC still offer a course that blends linear algebra and differential equations together?
Yes, that's my question.
I don't know the answer to that, but I'll give you a little bit of my own perspective on it.
Mm-hmm.
So differential equations and linear algebra are 2 math courses, right? Like, they're not English courses, they're not computer science courses, they're not engineering courses, they are math courses, right? So one thing you have to keep in mind is that when you take a math course, it's always kind of, well, it should be at least taught as if you are a math major. I mean, it's just like when you take an engineering course, they're assuming that you're going to do engineering, right? So when you take a math course, there's a certain amount of rigor that has to be in the course, because you may need that as you move on and take more math. Now, here's why I'm saying this. When you take the ideas of linear algebra and you blend them together with the ideas of differential equations, you start to create a course that's very similar to a course offered in the engineering sequence. What are you doing, man? You're on video. You don't care? All right. Let's go. All right, so you start to create, of course, it's an engineering course, but it's not the same. It's engineering analysis, right? You've all heard of that course.
Yes.
Yes. So engineering analysis, man, I wish I was in my office right now at work. Engineering analysis is like the weed out course for engineers, and you probably have heard that. Because it takes linear algebra, differential equations, a little bit of Cal 3. It takes all these mathematical concepts, and then you start doing engineering problems, all right? And so students are like, what in the world's going on here? So if you were to take differential equations by itself as a math class and take linear algebra as a math class and then go into engineering analysis, you won't freak out because you'll actually have the mathematical foundation and then you can start doing the applications. Engineering analysis is like you have to do it all at one time. You got to learn the linear algebra, the differential equations, and then go apply it right away. It's challenging. Students get through it, okay? I'm saying for me, I do not believe personally in offering a math class that blends the two. Like
Would you recommend taking them at the same time, like same semester?
Take them together. Yeah, you can take them together. They're independent. Like you can do differential equations without any linear algebra. You can do linear algebra without any differential equations.
Okay.
And it really isn't, you know, math is a very straight course until you get past Cal 2. Like once you get past Cal 2, like it starts to branch. So you do, you know, Cal 3, you can go do linear algebra, you can go differential equations, you can go do numerical analysis. You can do all these different courses. Most people think like to take math, it's always like one followed by the other, off by the other, but no, it does branch out. So I'm not suggesting that you go take those two courses. I think it's just more sharing my own personal view on it, is that engineering analysis is tough because it's a lot of material. And just if you broke it up and knocked out the math part first, just got those concepts down, then you can actually enjoy the application of it.
Okay. All right, thanks.
I don't think I answered your question. I don't know exact doing. I have heard some colleges will let you take differential equations, linear algebra, and they will accept those as a credit for engineering analysis. I've heard that. And
Okay.
I would highly not recommend that. Like I think you really have to do engineering analysis 1 in order to do well in 2.
Mm-hmm.
I don't think you can do linear algebra and differential equations by themselves and then go do EA2. You've got to have EA1.
Okay.
How many engineering majors do we have? A lot.
I'm one of them.
2, 3, at least 3 here. No. What type?
Electrical.
Electrical,
I'm doing civil.
civil, electrical. Joseph, what did you say?
Mechanical.
Mechanical. I was a mechanical engineering major.
Oh, nice.
Yeah. I went into college as an architecture major because I didn't know what the hell I wanted to do. And then I went to mechanical engineering, and then I went to physics, and then I went to math. So that was my journey of majors.
That's funny because actually I wanted to do architecture pretty much throughout high school and then decided on engineering.
Yeah, I did a lot of drafting classes in high school, old school, like when CAD first came out. And so like, you know, but I did a lot of my own designing stuff, and I always thought it'd be cool to be an architect.
Mm-hmm.
And I just didn't take it real serious in college at the beginning. So I switched over to mechanical, and for some reason I liked physics. And then while I was taking physics classes, I actually my math teachers were telling me, like, what's your major? And I was like, physics. And they're like, you should come over to the math. And so I kind of, yeah, it's a longer story than that, but that's the short of it. Yeah, well, engineering is fascinating. There's so many things out there, I think a lot nowadays, you almost have to have a minor in CS. It's like you almost have to have some computer background to do any engineering. Because no matter what field you go into, there's going to be some software, some sort of software aspect of it. My brother is an electrical engineer. He went to Boston University, and then for grad school, he went to Georgia Tech. And when he got out of Georgia Tech, his first job was for the company that made the software that he was using while he was a graduate student at Georgia Tech. So while he was at Georgia Tech, they were using some software, and he got really, really, really good with that software. So he got hired on by the company that makes the software as the guy who answers the phone. So he's coming out of, grad school with a master's degree in electrical engineering and is doing tech support, right? And now he's a manager of R&D, research and development, for that company. So he worked his way up through the company, and he had to go in at the bottom. But what got him in there was that familiarity with the software. And so I always think that no matter what engineering you get into, civil or electrical or mechanical, you always want to be trying to acquaint yourself with the software that's being used in that field as soon as possible. And a lot of times you can get student versions of software that are cheaper, and they understand you're just trying to learn. And everyone here has heard of Wolfram Alpha, right? The website. There's, I guess, better stuff out there nowadays, but Wolfram Alpha was like the pioneer of web-based math, right? Well, right now, they make when you go to Wolfram Alpha and you type something in, the brains behind all that is a program called Mathematica. And Mathematica is, I think they're on version like 11 point something. I started using Mathematica as a student when they were in version like 1.4. So even as an undergraduate student, I was using the software that was available to mathematicians at that time to try and solve problems. And, so, I mean, it's only helped me in the way I deliver. You'll see in the Cal 2 and the Cal 1, I do a lot of animations and stuff, and I'm using Mathematica to do it, which is really just like C+ code. It's, so I had to learn to code. I just kind of did it on my own, self-taught. And so, no matter what your major is, if, engineering, no matter what it is, I always say, try and back it up with something, computer science, something CS, get into coding, or just get familiar with some programs. And get your foot in the door somewhere, man. Go intern somewhere, go work for bread and water at some place, get to know the people there, because it's important. I mean, you want to do something you love, right? Like, you don't want to go and like sit there and be like, oh, this is what my degree is going to get me, and they're all miserable, like they hate coming to work. Like, you don't want that, right? You want something better for yourself. So make sure you're doing what you want to do, and that you enjoy waking up and going and doing it. Otherwise, it's not worth it. What else? Anything? Majors? How many of you are working? Anyone working right now? It's kind of, yeah. Full time? Part time?
Not really.
I'm actually working. I work for a civil engineering firm, so I'm working from home. Yeah.
Good. Yeah. So you got your foot in the door. You like what they do?
I do. Yeah, I do. I work as a drafter, as a designer. So
Cool.
now I wanna.
That's cool.
Yeah.
That's good. yeah, you got to get your foot in the door, and a lot of times then they're just waiting for you to get your credentials.
Yeah.
They can start moving you up.
Yeah, that's how it is with me. I'm a part-time dispatch supervisor for UPS.
Uh-huh.
So, but I started actually because my dad, he worked in the plant engineering department, and he got me into their industrial engineering department. It was so that's all they're doing. I mean, and they're offering like up to, I believe it's like $2,600 a semester, like to pay for school and stuff. So it's
Good.
Yeah, that's cool.
Yeah, it's good. And I mean, like I said when we were talking earlier, it's that job, you're never going to be, trying to find some convergence or divergence of a series. Like that's never going to happen. Now, but will you be faced with trying to solve a problem? I mean, yeah, I mean, it's about problem solving. That's what's about. I was telling you about my brother, right? So they asked him a few questions in his interview for this company he's working for now. And this was just to go answer their phones, right? So one of the questions they asked him was, I'll give you the less interesting one first. It was, they said, okay, you've got 10 coins, right? They all look exactly the same. And you have a scale, like a balance, right? So you've got these 10 coins, you've got this balance scale. One of the 10 coins weighs less than the other 9. So 9 are identical. One of them is a little bit lighter than the others, but you can't tell if you couldn't hold it in your hand and tell. So anyone want to guess what the question was?
Where do I place the heaviest coin?
You understand? So you have a scale, like a balance, right?
Yeah.
You know what I'm saying? Like a little teeter-totter with a fulcrum here. And you've got these 10 coins, 9 of which are identical, 1 that's lighter. Their question was, what is the minimum number of weighings or balances that you would have to do to guarantee that you could find the lightest coin? Right. That has nothing to do with calculus. That has nothing to do with any engineering class he ever took. That has to do with just thinking, right?
Trial and error.
Yeah. Anyone want to take a shot? So if you take a shot and you give me an answer, you're going to have to explain. So what is the minimum number of weighings or scale balances that you would have to do in order to guarantee you're going to find me the lightest one? Because you could get lucky, right? Like you could just pick one and pick the other and put them, and then and you just could get lucky on the first try, right? That's not what they were asking them. They said, what is the minimum number of weighings it would take to guarantee you're going to find it? I'm going to let you think about it for 30 seconds. I'll play the Jeopardy music in the background.
It's 10, right?
Yeah, that's what I was thinking. Like 1 out of 10, because there's 10 coins.
You would have to weigh all of them, right?
Yeah,
I don't know.
but I don't know how to, I guess, explain it.
I thought it was like a trick question or something.
It'll be 11.
What's that?
You would, I guess, weight all of them at the same time. No, that wouldn't make sense. And then divide it by the 10, and then make sure which one weighs. No, I'm confused.
What do y'all got? Anything? No?
Saying 10.
10 weighings? You should be able to do it in 10. Can y'all see my screen?
Yep.
Yeah.
Okay, so there's my little scale. So you got your 10 coins, right? The correct answer is 3. So here's how you do it. You put 5 of them here and 5 of them here, all right? So one side is going to go down, right? So let's say that this side goes down and that side goes up. So now you know that the lightest one is somewhere in here, right? Okay, so you throw these out. Okay, and we start over. We've done one weighing. We've done one. Now, what do I do with that stack of 5 that I just have?
2 and 2.
2 and 2. 2 here, 2 here. Right, and then I have this other coin sitting here. Here's my coin, it's just sitting here, right? So what could happen right now?
They could stay even.
Yeah, they could be balanced, right? In that case, you know this is the lightest one. But that you just got lucky, right? You just got lucky. So what happens if this side goes down and that side goes up?
You avoid the ones that go up.
Yeah.
Yeah, so it's got to be over here, right?
Mhm.
Okay.
So now you've done the second weighing, and now you're going to start over. You've got 3 coins still, right? The one that you left here, and then the 2. So you know it's in there, right? So you're just going to put 1 and 1 now. Now you got it. One of those sides is going down. So 3 is the minimum. So you're sitting there trying to get a job, right? And that's the question they ask you. It's the first question. The second question they asked is a little more interesting. Y'all want to hear it?
Yep.
Okay.
Let's hear it.
So you have to pay attention to the wording here. I'll repeat it. Okay. I don't know how many times I repeated it to him, but I'll repeat it. All right. So here was the question. All right. 2 archaeologists stumble upon a cave. One of the archaeologists goes into the cave. Shortly thereafter comes out and tells the other archaeologist, hey, I've just discovered the perfectly preserved remains of the first human being ever. The question is, how did he know that he had discovered the perfectly preserved remains of the first human being ever? So I'll do it again. 2 archaeologists stumble upon a cave. One of them goes in. Shortly thereafter comes out, tells the other one, I just found the perfectly preserved remains of the first human being ever. Question is, how did he know he had found the perfectly preserved remains of the first human being? All that studying, can you imagine that question? All that book work.
Would it be because they didn't have a belly button?
That is it. Excellent.
What?
So the key words in there are perfectly preserved remains, right? So perfectly preserved remains means that the human that they found is preserved, is perfectly preserved. So every aspect of that human should be identifiable. And the first human could not be born, and so it couldn't have a belly button. Interesting. Very good. So that's just the way you're thinking, right? I'm not sure where that comes from, right? You know, not sure what type of problem solving you do in your life, but that's the problem solving they wanted to make sure he had. You got them both right. You got both questions right. So, you know, that's what you're trying to build. You're trying to build yourself up to the point where you just think a certain way, you know? All right, cool. All right, well, unless there's anything else, I think my wife's home, so I think I'm gonna go see how her day went. She's in the medical field, so, you know, she's still working a lot.
I'd imagine.
Okay, well, I look forward to meeting you again in the Zoom. You know, maybe there's a way that y'all can meet in Zoom without me, you know? I'm not sure if y'all can set up meetings and invite each other, but maybe we can get some sort of you know, in case y'all wanted to get together and discuss any homework problems or just topics or something like that, maybe especially before exam 2 and 4, maybe you just want to get a study group. You know, if we get enough feedback, maybe I will have some some review sessions, and that usually will draw people, you know. And there's a way that I can break y'all out into little work rooms where y'all can group up together, and I can give you some problems to kind of go after. So, all righty. Okay, well, thank y'all for showing up, and I guess you know what you need to do now, right? Get to watching videos and working on WebAssign homework, and keeping pace. Reach out to me if you need it. I'll send something out soon with the whole when are you available.
Sounds good, sir. Thank you.
Okay,
Thank you.
thanks for your time. Talk to y'all later.
Yep.
Later.
Later.